Okay, so we're looking at a question from the 2006 by hand exam, exam 1, and it's a question where we need to graph a trig function. And the first part of the question just asks us to find the amplitude, which for a trig graph is the coefficient of the trig function, in this case cos. So 5 is the amplitude, and the period is 2 pi on n for a cos and sine graph, and that's 2 pi on the x coefficient, which is 2 pi on 2, which is pi. So our period is pi, our amp is 5, and each one of those is worth 1 mark each, and it's 2 marks for that part of the question, which is quite simple. Next part of the question is a little bit more involved. It's 3 marks. It involves us to graph this whole function over the domain negative pi to pi, and we need to label axis intercepts with their coordinates and also endpoints. Okay, so what we need to do here, well, we will need to use the unit circle and exact table of values, so you do need to know those. And we'll start by graphing the intercepts, and we'll start with the y-intercept. So y-intercept when x equals 0. So what we're looking at is where x equals to 0. So we're going to substitute 0 into x into this function and see what we get. So here's our function. Instead of x, we're going to put 0, and it's pi on 3 just to finish off. So to simplify this, we've got 5 cos and 2 times pi on 3, 2 pi on 3. So what we need to do, we need to find out what is cos 2 pi on 3. Let's go to our unit circle. So 2 pi on 3 is nearly pi. So that's 2 pi on 3 all the way around there. And in fact, it's pi on 3 short of pi. So when we're doing exact table of values, we need to make sure we're in this first quadrant here. So we'll need to use symmetry and get that line back in the first quadrant. So if that's pi on 3, using symmetry, this angle here is also going to be pi on 3. And for the first quadrant, we're going to have a positive cos value. For the second quadrant, the cos value will be negative. It'll be the same absolute value, but negative is what we want. So we're looking at cos pi on 3. Cos pi on 3 in our exact table of values is here, so it's equal to a half. So we're looking at basically negative a half here. So our y-intercept would be 5 times negative a half, which is minus 5 on 2. Okay, that's our y-intercept. So going to our graph, and minus 5 on 2 is 2.5, minus 2.5, which is here. And we need to label that. So we'll go 0, minus 5 on 2. That's the coordinate. And also because the period is pi, that means this point should repeat itself every pi. So if we move pi to the right, which takes us to the end of the graph, it's going to be also minus 5 on 2. And if we move pi to the left, and that takes us to the end of the graph on the left, it's going to be minus pi and minus 5 on 2 is going to be the coordinate. So we've already labelled our endpoints. Let's find the x-intercepts next. Okay, so x-intercept is when y equal to 0. So what we need to do is make y equal to 0 and rewrite the equation. And x stays there. So what we'll need to do is solve for x, solve for those x-intercepts. So first thing we can do is divide by 5 both sides, which means 0 divided by 5 is 0, 5 divided by 5 divided by 5 is 1. And the next thing we have to do is take the inverse of cos, move this cos to the other side. So what I'll do, I'll just actually leave it on the right hand side of the equation. So taking the inverse of cos gives us that on the right hand side of the equation. On the left, I'm going to move this over to the left hand side of the equation because I want x on the left hand side of the equation. So that's what we have so far. We have to divide both sides by 2. Sorry, before we do that, we need to find out what values give us 0 for cos. So looking at our unit circle, 0 for cos, remember cos is on the x-axis, so 0 is here. So pi on 2 is one solution, and the other solution is 3 pi on 2. So that's our two solutions, pi on 2 and 3 pi on 2. And on the left hand side we still get the same thing. Okay, next thing we need to do is divide both sides by 2. Okay, so that's just going to become a 4, and that will become a 4, and that 2 disappears. Okay, so we've got that. We need to then subtract. pi on 3 from both sides of the equation. So we've got x equals pi on 4, take away pi on 3, and for the other solution, 3 pi on 4, take away pi on 3. So when we're dealing with fractions, we need the same denominator. So for 4 and 3, the lowest common factor would be 12. So that becomes 3 pi on 12, and this would become 4 pi on 12. 3 pi on 12 minus 4 pi on 12 is minus pi on 12. So that's one of our x solutions. And also over here, let's make that 12. That'll be 9. That becomes 12, so that's a 3. 9 pi on 12 minus 3 pi on 12, that should be 4 pi on 12 actually. 9 pi on 12 minus 4 pi on 12 is 5 pi on 12. Okay. There are two solutions. So looking at this graph, every single interval there is pi on 12. You can count them up, but there's 12 of those in there. So minus pi on 12 is here. Okay, so we've got to label our intercept. So that's going to be minus pi on 12 and 0 for y value. And over here, 5 pi on 12, 1, 2, 3, 4, 5. And we'll label that 5 pi on 12 and 0. That's the coordinates. And the other thing is, we know that these points repeat themselves every pi, because pi is the period. Okay, so all we have to do is add and subtract pi from these points. If I add pi to here, I'm going to go all the way over to here, outside my domain, so that's not useful. But if I subtract pi from 5 pi on 12, I'll get minus 7 pi on 12, all the way down here. 1, 2, 3, 4, 5, 6, 7, right there. Okay, so we'll label that minus 7 pi on 12 and 0. And also, if I add pi to this point, add pi, okay, I'm going to come all the way over to here, which will become 11 pi on 12 and 0. So what I've done is labelled, found all my x-intercepts. I found most of my points for my graph. I should have also realised that my amplitude is 5, meaning my maximum minimum is going to be 5 and negative 5. So using that information, in between these 2 points must be a maximum. So right there is the middle, and the maximum would be 5. You don't have to find the maximums, it doesn't ask you to, so don't worry about that. Our graph's going to come up like this and go around, try and do a nice smooth graph, smooth as I can. In between these 2 points, which is here, it's going to be negative 5. The graph's going to go to negative 5 down here. Again, we don't have to label that point. It goes up, smooth as possible, and in between these 2 points, 5, up through there, and 5. In between these 2 points would be negative 5. Okay, so negative 5 down here, and going down and around and stop. Okay, our end domains, because we're including minus pi and pi, should be a dot. And basically we have all our solutions. We have labelled axis-intercepts with their coordinates and their endpoints. Okay, and that's what we need to do. So a bit involved there, but a very typical question will involve you solving this type of thing because of sort of trig graphs. Okay, so you need to know how to do this and be very comfortable with it, including your unit circle and exact table of values you need to know as well. And that will give us 3 points. Let's just have a quick look at the assessment report. And over here, question 4, we can see that the amplitude was 5, the period pi, and this was done very well. Average marks of 1.8 out of 2. The second part of the question, the graphing, we got our points right here. Out of 3 marks, the average was 1.1. So obviously not done very well. Let's just have a look and see what they say. Many students had difficulty sketching the graph and including all the required information in the correct form. It was disappointing to see the number of graphs that were either not smooth or not symmetric, or both. So try and make them smooth. Many students did not realise that the amplitude and period found in part A should be used for the graph, which was what we did. Although most graphs had an amplitude of 5, the period was rarely pi. Endpoints were generally located correctly but rarely labelled. X-intercepts were often incorrect and not written as coordinates, so we did do coordinates. We found the y-intercept, A few students also attempted to find the turning points, which you didn't need to do. Okay, so there's our assessment report. Always worthwhile reading, and please practice graphing and also solving for those trig functions.